participation. We talked about putting it into the Woodland Center for cooling the towers and stuff, but they decided.
That was ridiculous.
A lot of
Very
cleanup.
unique circumstance.
I went in four all the time, morning or whatever that was, Wednesday morning or whatever. Or Thursday morning, whatever day that was, when it actually snowed. And I thought, oh, I'll just pick up a few things. I knew it was gonna be crazy. It was like 6 o'clock in the morning. And I'll just run in and won't be late. It was like bread McGinn. There was one loaf of bread on the whole, I mean, it was ridiculous.
I think that's a good way to take care of it.
That is correct. I know, I talked to someone who said, oh, I got the bread was on the shelf, and I said, well, that's not what I'm looking for.
Yeah, well.
Well, I got cold, though, it's fine.
So now it's recording, you can see the sign on where it says someday.
I used to do medicine, I got a bag of cough drops. Just sat and coughed through the whole thing yesterday.
Stop thinking it's
Now, as soon as you click two, it's going to.
When I started,
I'm guessing
first of the year, I started losing weight. I was getting, I exercise a lot, but just kind of watching my calories. I've been 4'6" since the first of the year. It's gotta be tough with the fact that my
Microphones are in the middle, so we're trying to stay on this one.
that makes sense to me.
There's been some
This
weird
is
stuff.
this is stream internet. This rays out. After you.
Probably not.
That's also why you were over at the
Yeah.
And it should stay.
Pan those things around, so.
Okay, well,
Look at the back of our
yeah,
head.
my best behavior.
Well, yesterday was 2 sessions. Two different groups.
That's it. I'm not gonna say.
No, it's 4 different.
Yeah, I made them all. Yeah. It was Terra both entrances, you know. One's not bad.
And then let's take
trip
Wednesday.
today.
Yeah, so it really looks like we're getting ready.
Little wind help though.
Oh, yeah, pushed you right on down.
Sure.
Well, I don't know if she does. I don't know if I do.
Get ready to cover his mouth.
That's what he used to do.
Yeah. Retracting solar arrays. One of them.
Elizabeth will go out with us
Fuck away from the other
first,
one.
and you can ask her lead questions.
You want to sit toward the middle maybe?
Anybody wants to go to
One of
dinner,
those, do we have to do
and
something?
you get free access to Elizabeth and Rick, they're willing to go to El Toro at 5-ish.
That requires too much
So,
participation.
I don't know if you're as interested, but these guys might be interested.
Did you hear that email I sent you about that?
Monitor. Yeah, I looked at it briefly. I got it. It looked cool. I just.
And it's cheap. It's not expensive at all.
But I work okay. Back and forth. I was enjoying physically.
Then I can see better.
Work on your colleagues there. This is what's cool. I know if you guys have, we'll talk about this year later. What's cool is you don't actually have access to lead specialists for free very often. So if you want to go, here's our lead specialist.
I was just gonna say, tell Dan that I enjoyed the cookies.
Did you enjoy it?
I have.
Eat them already?
I've given them, some
I'll
of
bring
them
you
away.
more. We got a case left.
Well, I'm sorry to say I got in 2 boxes. I've given them to my goddaughter, so I'm gonna take them for lab week, but what kinds do you have left there?
I don't, we got some caramel pie.
Oh, those were good.
Some of those peanut butter patties, I think.
You just get something really slick.
And
Do you have the peanut butter sandwich one?
That's a good idea.
I sold the last one she had, I sold one of my.
Do you have any more of the Thin Mints?
Yeah.
I wonder, do you think the kids would like Thin Mints?
We can get more.
I want to play bingo for lab week. Maybe I can
Most of her construction is done though.
give special prizes with cookies.
I know.
That would be nice. That's it. Okay, well, I'll come over.
All right, you want me to bring you some?
Yeah. I guess I like the Thin Mints and those.
I'll
Are we live? We're ready to go? All right, if you folks can come on in and grab a seat. My name is Bill Heitzman, and I'm the campus president here at the Hastings campus for Central Community College, and I'd like to welcome all of you that are here locally and all of those that are out at each of our centers and the other two campuses, Columbus and Grand Island. So this is the second of a series of presentations that are being provided on the college initiatives with sustainability leadership presentations. Again, for those of you that attended yesterday's presentation and the introduction of that, again, just to make sure that, you know, the college has taken the initiative to look at sustainability issues for starting now and into the future, looking at our communities and what can we do better with our resources and in a number of different areas, not just waste and trash and those type of things, but a much broader perspective on sustainability. Central Community College, Dr. Smith, the board, and everyone here is an initiative by Central Community College, and Dr. Smith kicked it off by signing the American College and University President's Climate Commitment Letter. And I believe there's about 500 institutions around the country that have signed that and made the commitment to that. As the college has moved forward, certainly with these presentations, a series of these that are going to go on throughout 2013, the hiring of Manetta Khan, who is our sustainability coordinator, and really very engaged in helping all of us learn a little bit more about that and understand sustainability issues and what can we do that would impact that. Again, we're very pleased that you could all join us. I believe yesterday's presentation there were about 70 people throughout the college that attended, and I think right now I know there's a large number here, more so than yesterday, and I hope we have the same out and about. But with that, today's program at the 3:30, there will be a third presentation tonight at 7 o'clock for those that can attend that. Today is the basics of sustainable design, and it is my pleasure to introduce our speakers today. They will kind of jointly do the presentation. And first is Rick Carter. Mr. Carter is a Senior Vice President for LHB's Minneapolis office. LHB is a Minnesota-based architectural and engineering firm. He has worked exclusively on issues of sustainable design, promoting an improved indoor quality, energy efficiency, and resource efficiency. At LHB, he founded their Green Team in 1992. A multi-discipline team dedicated to incorporating sustainable design techniques into all projects. Rich is an adjunct faculty member teaching at graduate level sustainable design course at the University of Minnesota College of Design. And Rick is Leadership in Energy Engineering Design, or LEED Fellow, and is a Fellow of the American Institute of Architects. So, Rick, welcome.
Thank you.
Also with us in the presentation is Elizabeth Turner, and I believe a Grand Island native, so back in her home area. Ms. Turner holds a Master's of Architecture degree and a Master of Science in Sustainable Design degree from the University of Minnesota. She has over 7 years experience in architectural design, teaching, and research. At LHB, she has worked on campus master plans and multi-family housing projects. Elizabeth is especially interested in the design that equally supports economic, environmental, and social sustainability. So with the two of you, we welcome you not only to the Hastings campus, but also presenting to Central Community College throughout our entire 25 county area, not only through this, but also I believe on the web. So again, welcome, and I will turn this now over to Elizabeth.
Great, thank you for that warm welcome. It's definitely exciting to be back in central Nebraska after spending a lot of time away and studying sustainable design, to come back and share some of the things that I've learned with the community that really helped me to become who I am today. So today we're talking about the basics of sustainable design, really at the building scale. So that's where we're going to be focusing, kind of the architecture. We're going to start out by talking about what is actually sustainable design. What does it mean? Some different frameworks that we use to talk about sustainability. Rick will talk about leadership in energy and environmental design. The process that we use to design sustainable buildings, how it's integrated, and finally measuring sustainability of buildings through building performance. The second half of the presentation is really what does sustainable design look like at the building scale. So we'll talk about a few different categories, some of the strategies that you can think about when designing, and some of the benefits that those have at the site, materials, water, energy, and human wellness levels of design. And we'll end with giving you some things that you can think about and take away from our presentation. So first of all, what is sustainable design? The definition was developed in 1987, that it's meeting the needs of the present without limiting the ability of future generations to meet their own needs. We talk about 3 different kinds of sustainability. So the first that you might be familiar with is environmental sustainability, land and wildlife and our natural resources. The second is economic sustainability. So for something to be truly sustainable, it has to be economically sustainable. And ideally, environmental sustainability supports places that are rich with economic vitality. And the third piece of this 3-pronged sustainability focus is social sustainability. So having people have high quality jobs. I'm very fortunate to be in a job where I can work on issues of sustainability, and also promoting human health and wellness. So that's a really important focus. That's one of the reasons that we really seek to design sustainable things, to support the humans who live here, to support the economic vitality of the places we design sustainably, and also to support the larger environment. So these 3 strategies can kind of be summed up in this question. So if you want to think about what is sustainable design, how do we design sustainably, you can also kind of ask this question to yourself. How can we conserve resources and improve human wellness through smart design? So kind of the larger scale, and then really the things that you should think about when designing a sustainable building. So we know that there's a large environmental impact of buildings. These are some statistics Rick found when we first started looking at issues of sustainability. Although the US has about 5% of the world population, we produce 25% of world resource consumption and 40% of world waste. And buildings account for a large amount of electricity, water, and material use in the United States as well. So architects, engineers, and building owners have an opportunity to impact resource consumption and waste creation, and I know a lot of you are in the audience here today. One of the issues with sustainable design is it's very complex. So I don't expect you to read all of these and understand them right now, but know that by the end of this presentation, we hope that you have a better understanding of what all these different categories mean. So the first is topic. Things like site, water, energy, materials, human wellness. And you can see at the top right of the slide, we have some little icons that represent site, materials, water, energy, and human wellness. And these are actually developed by LEED. We use a lot of icons in sustainable design to help us kind of keep track of all the different things we should be thinking about, because the idea is that there are really all of these individual parts, all these individual decisions that we make that we really need to think about integrating and making more holistic decisions. We also need to think about the scale of the decisions we make on the building level and the community level, and how those have larger impacts and smaller impacts as well. So we talk about sustainability affecting everything from the global scale down to our regions and communities, our neighborhoods, and then even the individual person. The domains that I talked about, and then we're going to talk more about building performance. So these are just 2 examples of, there are many, many guidelines and rating systems that you can choose from to kind of help you understand the holistic approach to designing sustainably. So LEED is on the left. Rick's going to talk about that more in detail. And the Living Building Challenge is one that sets, well, LEED is more of a checklist. Living Building Challenge sets ultimate goals that people work to try to figure out how they can achieve, for example, carbon neutrality and reduce water consumption. So you can see there's a lot of overlap between these two rating systems. And I'll turn it over to Rick.
All right, thank you for having us. I'm going to talk a little bit about LEED. I would think that most people have probably heard of LEED. You may not know what it stands for or what it means necessarily. You may have been in a LEED certified building. It stands for Leadership in Energy Efficient and Environmental Design. And it's created by an organization called the U.S. Green Building Council, which I think someone said that your organization belongs to. Is that right? Yep. So you belong to it as an organization. And it has many different, the U.S. Green Building Council literally calls these products. So depending on what kind of a building you have, if you want to use it to guide your decisions, you can do it if you have a home. You can do it if you have a retail building. They even have a program that's designed for existing buildings. So you can take an existing building and put it through a process and get it to the point where it becomes LEED certified. And it's different in many ways because it's third-party verified. So somebody else looks at everything you do and says whether they agree that you've accomplished it or not. It's got international recognition, so if people are comparing campus buildings from one part of the country to another, they can do that. It's a little bit of an arduous process. There's tens of thousands of people involved through thousands of organizations, and every decision is based on consensus or voting. So it takes a long time for change to occur. They've historically named guidelines by the year that they get issued, and it always takes longer than they think. So we're using the guidelines now called LEED 2009, and they're in the process of revising them. And Elizabeth mentioned that it's a checklist. So basically what you do is you look at a project that you're doing, and you go through the checklist, and you get credits or points for everything that you're able to accomplish. And you're trying to convince somebody else that you've accomplished it by doing drawings. So by virtue of having a checklist and having these different categories, you end up with priorities. So you may not be able to read the exact numbers on here, but you can probably see the size of the bar. Energy is the biggest category, and it's the biggest for a couple of reasons. We'll talk a lot about energy in this presentation, in large part because it's the thing we understand the best. It's probably been 40 years that people have been looking really hard at understanding how energy is used in buildings. So we have a pretty good understanding of how that works. We don't really understand as well how human wellness is affected by buildings, and everything else is somewhere in between. So it's partly that it's more important, it's partly, and you'll see some of this too, that it's easier to prove when you accomplish something with energy. But the other categories that Elizabeth mentioned, site, water, materials, and our environmental quality are important. And they also have two categories in LEED which are unique. One is called innovation and design, which essentially means if you come up with something that's really good, or you do something that someone else came up with that wasn't in the system, but it's so good it can be recognized. And more recently, and I think even better, regional priorities are things where people who belong to this organization in various parts of the country come up with things that would be specific to your region, like wind, right? We were just talking about wind here. That might be a specific thing for here. So when you hear about a building becoming LEED certified, there's actually 4 different levels in any of the systems, whether it's LEED for homes or LEED for existing buildings. There's a basic certification, there's LEED Silver, LEED Gold, and LEED Platinum. And LEED Platinum is the highest level. So every category, some have different number of points, but every category has a cutoff for each of those. What I would say to people, I just said it earlier when we were talking to another campus president, if you build a really good, solid institutional building today, like a college building, you probably would be building a building that is in that category of being able to be LEED certified or LEED Silver. You have to literally follow very precise rules, so you're going to have to go through the checklist and make sure. But it's not like you're doing something completely different or spending a lot more money. Getting to a level of LEED Gold or LEED Platinum might be a little bit of a stretch and a little bit different, and that was the idea. This program went into place in pilot, I think, in about 1995. So even though you might have just heard about it in the last few years, it's been around for a long time. The idea is to do better than code. Building code requires you to do a lot of these things, but it's literally the lowest common denominator. It's the legal limit to what you can do. There's a very deliberate process. If you know of anybody who's interested in doing LEED, or you're considering it for yourself, and you can literally do it for your home, you go through a process of first registering with the U.S. Green Building Council so they know that you're out there and you get resources from them. And then there's a long process of keeping track of your achievements and documenting them. And there's actually 2 official points where you submit. You submit credits during design and you submit credits during construction. Sometimes, because you never meet the people who review the information you submit, you don't have a face-to-face dialogue. Everything is done digitally. It can be a little frustrating, actually. But there is a process you go through, and sometimes you have to make a case for a credit that you didn't get, or you make an appeal. But eventually, at the end of the day, a decision is made. And I think every project we've been involved in, and we've been involved in many, we've gotten to the point where at least the owner wanted to get, which is important. I'm not familiar with these buildings, but you might be. These are all LEED certified buildings in central Nebraska. And you can see there's a couple of different kinds. LEED NC is typically for a new building or a major renovation. Commercial interior is for when you're putting a space, and you can literally do this. If you rent a space in an office building and you're just doing the build out of your space, you can do LEED certification. We're actually doing that for our own space right now. It's a little bit of a challenge because you don't control as much as if you were building or renovating a building. So now I'm going to shift gears a little bit. We can certainly answer any questions about LEED. I sometimes do 8-hour trainings on LEED. So if you have questions when we get to the end, feel free to ask about anything. But now I'm going to talk a little bit about the process of doing going after a project that, for example, would have LEED certification. We refer to it a lot as an integrated approach. And the easiest way for me to describe it is what it's not. Really, the kind of the old way of doing design and construction is a very linear approach where maybe an architect or a design team come up with a building and a shape and a form, and then it's handed off to people who do design around the building relative to site, people who do things inside the building like structural, mechanical, electrical, and that doesn't really work to make the building very efficient. You really need all those people talking at the same time. And you'll see that kind of reinforced throughout our presentation. The biggest decision you make on putting a building on a piece of land in terms of its energy efficiency is its shape and orientation. So if I'm going to put a building down and shape it and orient it for other reasons and come back later and ask a mechanical, electrical engineer to make it efficient, I've already eliminated a lot of their potential. The challenge is we can't physically or affordably have everybody on the team involved all the way through the process. It just doesn't work. So it becomes a very, very balancing act of when we bring people in. And it's not just the design team. This would resonate with people in the room. It's having the people who are going to run the building when the building's done be in the room when you're designing the building. Because that doesn't happen often. And that's a big mistake. Those people know how the building ran before, if it's a renovation or the building that is being replaced. And you really have to have everybody involved. You have to have people involved that are buying equipment. I'm not sure if we're really going to go into this today, but we're finding a lot of the energy use in buildings is not from the heating, lighting, cooling, but it's from the things that you plug in, which comes later. Someone comes along later and buys equipment. So you have to have all those people involved throughout the process. And we use these descriptions like pre-design, design, and operations. It's really just making sure that those things are overlapping and that we're not exclusively introducing people at certain points. Another way to think about this, and I'm not going to read through all these words, you just think about it basically from left to right are the things that we can do from the beginning of the design process to the end to affect energy efficiency. We talk about energy modeling, and Elizabeth will talk about a specific example. When we design a building today, we can build the building in the computer and know exactly how much energy it's going to use. So what often happens is we design the building and we get to the point where we know pretty much the way it's going to look, We have its shape, we have its major materials and systems, we put it in, we model it, and we say, oh, that's more energy than I want it to use, so let's change some things. Let's put in different light fixtures or more effective ventilation or different controls. And what we've done is we've lost a lot of the opportunity that we had in the beginning in terms of the way we shape a building or the way we orient the building or what skin we put on the building. So we really have to be having that discussion. And I'm just using energy as the example. You could apply this to stormwater or human health or materials or whatever it is you're trying to improve on. Energy, again, is just the one that we understand better. So we'll tend to use that as an example. So I'm going to shift gears just a little bit now again and talk about, it's not just about having a set of guidelines or a checklist or even just the process of going through integrated design. For us, it's really about having an understanding of what it is you're trying to accomplish. What's the measurement that you're trying to accomplish? And lo and behold, it turns out we can actually measure a lot of things with buildings, like energy performance. Not only can we predict with a computer model how much energy the building is going to use, but the building has a meter. We know exactly how much energy it's using. The problem is we don't tell the people that are operating it or the people who designed it so that they can use that information to make positive change. So that's changing now. In the last 5 years or so in our firm, we've probably been predicting the energy outcomes for 15 years. It's been about 5 years that we always go get the energy performance and compare it back. And comparing it back once probably isn't enough. Annually would be great. Monthly's better. You know, if you could do it in real time, that'd be the best. So the terminology, and you don't necessarily have to remember this, but someday you'll say, I've heard that before. We use energy use intensity, and we call it, the makeup of it is kB2 per square foot per year. So basically that's all the energy that we use in a building, and it doesn't matter. It can be burning cords of wood, generating kilowatts of electricity, therms of gas. We can convert those all into a common metric called a BTU, and then we normalize it over square foot and time. So what I tell people is, for me, after 5 years, it's starting to sound like miles per gallon. So I know the energy use intensity of a building. I know that building, and I know it's 42, so I know that if it's higher or lower than that, I know that there's something going on. So I was thinking about this. I drove from Omaha to here in a rented Prius today, and the panel's filled with controls. I have a gas gauge, and I have a speedometer, and I have an odometer, and it's telling me my current mileage and how much I'm using gas and how much I'm using electricity. The way we operate buildings today, many times, would be like if I drove across from Omaha and tried to not run out of gas or get a ticket without any of those controls. So what we're trying to do is give the building owners and operators those controls. And it's not easy. All the buildings have meters, but they weren't designed to tell you how much energy you're using. They're designed to create bills for you to pay. So we're working through this process, and we'll talk about a lot of different ways that we're doing it. We certainly haven't perfected it, but you'll get some ideas as we go through. Oops, backwards. So again, we keep using energy as sort of the example here. We've done this, and you'll see examples. Most buildings have water meters, which is fantastic, so we can get water data. It's a little harder to compare to or know what to predict, and water's not quite as much on people's radar, depending on where you're at. I know in Minnesota, we're surrounded by water. People think water, it's so cheap, why would we measure it? Well, if you look at what happens in other parts of the world or other parts of the country, you'll understand why, and we will be doing that everywhere soon. We also have figured out ways of measuring things, and I think Elizabeth will show some examples of waste. Human wellness is a little bit more difficult, but we're trying in every category to end up saying, if we're going to do all these great things in a checklist, what is it we want to accomplish, and how do we know if we actually did? So that we can feed back that information and people can use it in real time. So again, using energy as the example, and this is really, it was a slide kind of like this that got me thinking about the actual need to measure. So I think we probably have a slide or two that talk about carbon and greenhouse gas emissions in here. It doesn't matter if that's what's important to you or if it's reducing your energy consumption. They pretty much go hand in hand. If you look at a map of US greenhouse gas emissions, a pie chart, it'll look exactly like this energy use chart. Essentially, about a fourth is from transportation energy, which is vehicles. About a fourth is from process energy, which is industrial process, which actually mostly occurs in buildings. But the part that gets me as someone who gets up every day and creates buildings is half of it is from building operations. So again, it doesn't matter what your motivation is, if it's to save money or reduce greenhouse gas emissions, have cleaner operations, reducing energy in buildings is a really big deal. So see, I have multiple slides here, so if people who are online can keep up I'm going to talk in a minute about a program called Architecture 2030, which is really a way of thinking about the potential we have to reduce energy in buildings. I'm an architect, so I kind of know how this works in buildings. I'm sure there's a comparable methodology to think about transportation. The thing with buildings is we have a lot of buildings. So we have billions of square feet of buildings in the US. Between now and the year 2035, a fair amount of those buildings are going to disappear because they've just reached the end of their useful life. You see it all the time, buildings get demolished. A very, very large portion of what's left over are actually going to be substantially renovated, just like walking down the hall here. We're constantly renovating buildings. And we may not be renovating them just to save energy, but we're often replacing windows, replacing roof, dealing with insulation, boilers. We're often dealing with the things that change energy. And this part still blows me away, the amount of anticipated new construction between now and 2035, that's only 20 years away. So basically, almost 75 or 80% of the buildings that will be on the ground in the year 2035 will either be new or substantially renovated. So that's like a new fleet. So everything we do now, we have this potential to make buildings much more energy efficient. So one approach, and we use, and in fact I think we've got some slides that talk about a very specific approach, is an approach called Architecture 2030, which basically was created by an architect who recognized what was going on in those two slides. Half of the energy in the US is used in buildings, and we're making a substantial change in our building fleet in terms of replacing them and building new. So what he said is, by the year 2030, when you design a building, when we design a building, or you are involved in designing a building, that building will be, and I'll tell you many terms that people use to describe this, carbon neutral, net zero. What that means is it'll produce as much energy as it uses. So maybe it'll have solar panels on the roof, maybe it'll have a wind turbine, maybe it'll have something I haven't heard of yet, but it'll have a much lower amount of consumed energy so that it can actually replace it. So as to not wait until 2029 to figure that out, he set the system up so that we actually reduce by 50% when he thought of this in 2005, 60% today, 70%, et cetera. So we use this in our firm. So when we design a building today, we try and figure out what the average building of that type would use, and we try and design that building to use 60% less, which is a challenge, but it's, we're up to it, and that's what we're trying to do. I think maybe you're going to talk for a minute.
Yeah, I get to jump in and kind of explain the great altruistic effects that designing buildings this way has. So carbon neutrality is one of the goals. One of the goals is to save energy and really reduce the operating costs of your building. But when we do this, we can have an impact on global climate change as well. That's the opposite side of that scale I talked about that we use in sustainable design. So there are three numbers that really can kind of explain why carbon matters. Carbon, and you saw how much of carbon comes from buildings. So 2 degrees Celsius, or 3.6 degrees Fahrenheit, is really kind of the global scientific agreed upon number that it's the tipping point in climate change. We've already raised global temperatures of nearly 1 degree Celsius since the Industrial Revolution. And 2 degrees is kind of, if we go above that, it'll be really difficult to overcome and make the planet a place that's really habitable for human life. So in order to not get to 2 degrees Celsius, it's not too late. We can still, we still have about 565 gigatons of carbon dioxide emissions that we can put into the atmosphere. The problem is that's not that much. So if you combine the red and the green, this represents how much gigatons of carbon dioxide equivalents, about 3,000, is known to gas and oil companies, but also some of the largest countries that have known reserves of fossil fuels. So these are, this is energy that's planning to be burned in the next couple decades in order to keep these companies on their planned path of growth. So it's really a critical time for us to stop, to reduce the amount of energy our buildings need to kind of stay within this green carbon limit.
So I'm going to do just a couple of quick slides to talk about the relationship again between carbon and energy, and talk about a program we have in Minnesota, and then we're going to go through each of the various sections and talk about site material and water. So in Minnesota, a law was passed about 5 years ago that requires all public buildings that receive general obligation bonds to meet that Architecture 2030 challenge. So we've been fortunate to be involved, even though our core business is really we design buildings, we get involved in projects like this a lot where we get a really interesting perspective and understanding. So essentially what we do, and I'll show you a couple of specific examples, we look at a building and we say, what is the average energy consumption of that building? And it's not as easy as it sounds. We come up with computer model ways of doing that. And then we say the goal is to reduce that by 50 or 60%. We actually put the building into a computer model, like I said before, and we can come up with how much energy it's going to use. And it's very precise. If we build the building exactly the way we put it in the model and operate it exactly the way we put it in the model, it's physics. That's how much energy it will use. That never happens. It always gets built a little differently, and it's always operated a little differently, but we can usually track that. And then again, over time, we can go back and we can get the energy data from the utility companies or from the owner, and we can do the math and do the comparison. So we were lucky enough to be involved in the beginning of the project where we were trying to figure out if this was achievable, because people are giving away bond money to build buildings all over Minnesota, don't want to give them a requirement that they can't do or one that they can't afford. And again, we were at the very beginning of this, and we know it's going to get harder over time, so we wanted to make sure it was able to be accomplished. So we did a kind of a case study evaluation where we took 12 of our own buildings and maybe 1 or 2 of others, and we actually looked at them from an energy standpoint, and we said, let's see if my pointer works. All right. Oh, all right, I'm just going to point with my finger. The far left vertical bar is the goal we were trying to reach. So this is a weighted average of all the buildings. We had to go back and do research, but we were able to pull out the energy models for each of these buildings and come up with a number that was just slightly higher than that goal of what we predicted they were going to do before we built them. And these buildings had all been built and operating for a couple of years, so we were able to go back and get the last year energy consumption. And as you can see, the 65 is slightly higher than the goal, which is exactly what we wanted. These were buildings that owners had hired us who wanted to do very energy efficient buildings, so we knew that it was doable, but it wasn't easy. And then, and I've got a couple of slides that'll show this, if you look at the comparison between the energy in BTUs and the carbon equivalents in tons, they're almost identical. And that's pretty much always the case. If the energy model and the target and the outcome are of equal utility types, if it's about half gas and half electricity, they're going to stay the same. If one were to change dramatically, then you'd see a difference. But essentially, the way we present it in Minnesota is, don't worry if you don't know what a ton of carbon is, just figure out what a kBTU is. And that's, you know, for the engineers and the architects, we can figure that out. I'm going to talk about the cost figure on another slide, I think. So this is one particular college building that we're working on. It happens to be a student center for a metro area campus that got bond proceeds, is required to meet this program. And we came up with the standard, and we've done the model. The building's been operating for a little under a year, and we're waiting to see what the first year's operation is. But what I notice about this that drives change is we also, Elizabeth and I, work on a project where the 54 community campuses in the state of Minnesota, I don't think we have a slide on this, we help them measure all their energy consumption and water consumption every year, and we've done it for 4 years. So on a college campus in Minnesota, and this literally happened to me, I'm in a meeting talking about this building, and a VP of operations walks into the room and says, what is the KBTU per square foot per year of this building that we're designing? And that would be unheard of. It still is relatively unheard of, but it shows an awareness not just at the people designing the building, but the people paying for and running the building as well. So I think from there, we're going to go into talk about other strategies.
This is the slide for cost, if you want to talk about that.
You know, I think I've got it on Quality Bike with 3 bars, so thanks, but I'll come back to it. Oops, now I clicked in.
Okay, now this is the part where we get to go through site materials, water, energy, and human wellness, and give you some actual strategies that, or best practices that we think do a really good job of affecting the performance of our buildings and sites, and talk about some of the other benefits that come along with doing that. So the first is site. So one of the first things you can do with designing sustainable building is choose a location that makes it easy to get to, not only having to depend on a car, but thinking about people who might want to walk or bike as well. Really reducing paving and maximizing infiltration. So right here we're above the Ogallala Aquifer, and infiltration matters a lot to us. We get a majority of our water from the aquifer, so we want to make sure that we're recharging the aquifer and putting as much water that falls on the site through rain back into the aquifer. So this is one of the examples to the right of one of the ways we can do this. You'll see that there's some vegetation on the site, but we've also designed half permeable paving. So you can see there's kind of a line in the bottom right-hand side where the water is just staying above the asphalt on the top, flowing right into the storm sewers and into the rivers, and then right out to the Gulf of Mexico. On the right-hand side, it's actual pervious asphalt, so the water there is draining and filtering through the soil and getting down to the aquifers where it stays and where we can use it in our buildings and for agriculture and for other needs in the state. Another thing that works really well to reduce water consumption on the site is using native plantings that might not require as much irrigation as other as other plants would. Collecting the water data for the Minnesota colleges, like Rick said, we've seen that really the major use of water is actually for irrigation. Green roofs are one strategy we see in cities for capturing water, not as necessary here in the middle of the prairie where you have lots of land to capture that water. And then finally, alternative transportation and thinking about that when you're designing sites. So some of the benefits of designing this way, there's less of a need for artificial watering, depending more on rain. Reduced need for fertilization and pesticides when you have native plants that are able to thrive, which means that there are reduced costs for operating. You don't need people to go out and really prune the plants as much as you might need to in other cases. This is an example of some native landscaping near one of our housing projects. So we do have, it's kind of a mix of the traditional grass and then having some places with more native plants that also attract more species of wildlife. Being able to filter water into the ground instead of letting it run off into lakes and rivers improves water quality in those streams. And finally, when we design this way, we think that the places are pretty beautiful with these lots of flowers and native plants growing there. So throughout these 5 different topics, we're going to be coming back to quality bicycle projects. So this was a project that LHB designed a few years ago. The owners wanted to pursue LEED Gold certification. And LHB saw this as an opportunity to start measuring the performance of this building. So it was designed to perform well, and we came back after it had been operating for a while and measured the actual performance of the building. So on the site, what this measuring performance looks like is stormwater runoff. So the existing the standard and what was required in a regulatory process was that no more than 4.3 cubic feet per second could run off. And you can see on the picture at the right, this is actually a test. This is how you can test for stormwater runoff. It was found that it's actually 1.3, so operating well below what was required. On the material size of things, this is strange for an architect to say, but one of the biggest strategies that we have to reduce material consumption is to build less or don't build. So we really try to talk with clients and see what their needs are and if it can be met in either existing space that can be renovated slightly or can be met in other ways. The second strategy is to build with less. So one thing you'll see in this room, there's a drop ceiling, and then there's another ceiling above it, and we're hiding probably some mechanical systems up there. But in the image to the right, this is an affordable housing complex that LHB did, and one of the strategies was simply not to have a drop ceiling in this area, and to finish the ceiling and the mechanical systems so that they were acceptable for the public to see. One of the other strategies is to increase the durability of the materials that we put into buildings so that they're not required to be replaced as frequently. Incorporating salvage materials that we might find from other projects, or adding some historic elements into the new buildings that we create. And finally, decreasing construction waste. So there's quite a bit of waste that is created during the construction process. I'm sure you're familiar with that. So trying to decrease that is an important strategy. So some of the benefits are less initial cost for materials. If you use less materials in the building, you're going to pay less for that building. The longer life for the building itself, lower cost for maintenance, and if we can reduce some of this construction waste, there are lower disposal costs and less landfill use. So looking at our example of quality BISO products again, we measured the amount of waste produced in the construction process, which was just over 5,000 tons. And actually a great majority of that waste was able to be recycled and diverted from the landfill and used again. Moving on to water. So one of the biggest strategies that people think about is low flow fixtures. So using showers, toilets, waterless urinals, and sinks. Usually they add there's a little more aeration in the water, so you don't feel the effects as much, but you can get just as clean and use less water. The second thing to think about is using water efficient appliances. So this includes dishwashers and washing machines. And then these are two strategies that really integrate back into the site strategy. So if you have a building with a large roof area, you can actually capture that rainwater, store it in a cistern, and use it for irrigating the landscape. It's free water that's falling on your building, so you don't have to pay for that. You can use it in situations like flushing toilets if you clean it a little bit. And we're also seeing more people are using gray water in buildings. So gray water is water that comes from sinks and showers, stuff that's kind of dirty but not really dirty. So it just needs a little bit of filtering, and it can be used to, again, flush toilets, irrigate the landscape, or re-purified and used in other uses in the building. So strategies here, obviously, if you use less water, you have reduced utility costs. There are also reduced water treatment costs. So this is kind of more to that city scale of sustainable design. If you're getting less water dirty, the city won't have to clean that, and it saves money and energy for the buildings. Tracking the water data for the Minnesota campuses, I found that sewer costs actually are substantially higher than the cost of just the water alone. So that's a great strategy. We know in Nebraska the importance of keeping the rivers and lakes full, not only for irrigation needs, which is really one of the major reasons that we have a community in this area to support agriculture, but also for human enjoyment and the needs of a lot of the migrating birds that come through this area. And keeping some of that water for both agriculture and industry, which is really necessary to the economic success of central Nebraska. So really tying back into that economic, social, and environmental. Water kind of touches all three of those categories very well. At Quality Bicycle Products, we were able to design using dual flush toilets, low flow shower heads. They actually have showers for people who want to commute to work by bike, and waterless urinals and sensor operated water faucets. So while a comparable facility might use about 13 gallons per occupant per day, this facility was designed to use about 6 and actually use less than 4. Water is kind of one of those things. We don't have a great way of benchmarking it yet. There aren't a lot of people that are tracking their water consumption data that we can compare to. So it's starting to develop, and we hope that in the future we'll be able to track water use as it becomes a more and more precious resource. So Rick's going to talk about the energy strategies.
So the energy strategies are probably things that you're more familiar with, and there are far too many to name. When we do the energy modeling that I talked about, we'll have dozens and dozens of strategies, many different ways of using more efficient light fixtures, lighting controls that have occupancy sensors or daylight sensors. But one that we tend to overlook, and I mentioned this before, and Elizabeth is going to talk about a way in a minute that you can not overlook it, is the orientation of the building, where it actually has an effect on the amount of energy that we're using. And ultimately, using that analysis tool, both in the early phase and throughout, is probably the single thing we can do, the best single thing we can do. We list renewables, although it's kind of the last thing we recommend. You definitely want to do everything in your power to reduce the amount of energy that you're consuming first, just to get the bigger bang for the buck before you start buying solar power. And one thing we don't have listed up there, but it's something that kind of weaves into the measuring piece, we're finding, and it's pretty well, there's a lot of evidence about this, that if you have real-time feedback in how much you're using, you'll actually use less. So there's a fair number of examples of either community competitions where the neighborhood competes against each other, or dorms at universities where they compete against each other. There's a massive study of 30,000 buildings that are in a EPA website where they're maintaining that approximately 2% per year reduction, simply because the people who own and operate the building know how much energy it's using. Not how much they wrote a check for to the utility company, which probably wasn't the operator anyhow, it was probably someone in the finance department, but the people who are operating the building. So in terms of benefits, again, it's probably pretty intuitive. The best thing is it saves money. Energy is very expensive, and a lot of, an office building can cost $2 a square foot for energy. And if you're paying $15 a square foot to occupy the space, that's a big chunk of it. So saving money is the biggest motivation. Obviously, you can reduce the environmental impact. There's positive overlap with the human wellness issue. One of the biggest strategies that we didn't mention is daylighting. That's probably the single biggest individual energy saver, because if you introduce daylight and you can reduce artificial light, you actually typically reduce the need for cooling, and that typically enhances wellness as well. So that's probably enough. We've talked about energy a lot. You can talk about the modeling example.
So a little bit more on daylighting. I think this is where I'm at an advantage coming from Nebraska. I always know where north is and where east and west and south are. So, and you can also see the sun throughout the day. And my dad taught me a lot about that since he came from a farm. So I probably don't have to tell this audience very much about how the sun moves, but you know that in the summer, the height of the sun is a lot higher, and in the winter it's a lot lower. So what that means for sun is that in the winter it can get deep into a building, and in the summer if you build an awning out, you can really block a lot of that light from getting into the building. So this is a great way to take advantage of the sun, not only for daylighting, but to actually do what we call passive heating. So using the sun passively to heat our buildings. So this is an example. This is my parents' kitchen, and it's one of my favorite places to sit in the sun because we have these great giant sliding glass doors, and even when it's freezing outside and it's not quite spring and you're about to go crazy because it's just cold and it's not going away, you can sit in this little spot and be completely baked in the sun and feel like it's, it's 90 degrees and you're sitting out at the water park. And so I think if we think about using the sun in some of these ways, it's a great benefit. You don't have to heat your house quite as much. I know we can, sometimes in the middle of the day, the thermostat doesn't actually kick the heat on, but there are also clear benefits for human sanity, especially in the winter months, if you can let some of that light directly into the spaces. So obviously you don't want to get direct sunlight into buildings in the summertime. So that's something as simple as building an awning that goes out the right depth. And even the eaves of your house, if they're built long enough, can do that for you. Or planting deciduous trees so that in the winter there are no leaves and the sun can get in, but in the summer that light is blocked from heating up your house. So this is an example of a building that we went through the initial design process of building at a community campus up in Minnesota. So we decided to look at 5 different building massing strategies and compare them to the existing building. So you can see that buildings number 2, 3, and 5 performed a lot better. We think that they'll use a lot less energy than buildings 1 and 4, all other things being equal. And one of the reasons is because of something we call the massing of the building. So how much exterior glazing and wall area is there to the amount of floor area inside. And because there's there are less walls and windows in 2, 3, and 5, we're getting better energy use than in 1 and 2. Using energy modeling, we can also see where the building is using the most energy. So actually this energy model is set in the exact place on a global map of where this building would be. So we know that in green you can see how much heat is required for gas for this building. So compared to lighting and cooling and equipment and even hot water, gas is really, really the strategy we want to focus on. So we want to get as much of that passive solar energy gain as we can and really focus on insulation. So this can kind of tell which of these strategies that we've talked about really will give us the biggest bang for our buck. We can also use software to optimize. So we can look at the projected energy use intensity, kBTUs per square foot per year, and then look at different kinds of strategies. So look at if we have a highly insulated building or a to-code insulated building, and play with what energy savings we can get by increasing or decreasing the amount of insulation or a percentage of glazing, and a whole lot of strategies. So these are some of the strategies that we can play with and see what the percentage increase and decrease would be. So we can really experiment with a lot of these things before the building even gets constructed.
Want me to talk about this one? The thing I was going to say about this slide is this really is based on a computer model. So this is where we're looking at a building before it's built. And we're trying to get a sense for how much energy it's going to use in different categories. So we can break the building down in pretty fine grain. We can know how much energy we think it will take to heat it, cool it, light it, ventilate it, equipment, etc. And now when we build the building and we go back, and I'm going to use Quality Bike one last time, and we have it in kBTUs, we get therms for a year or month by month, and we get kilowatts, and we combine them, we just have one number. So we don't really know, we don't have that fine grain. So what we've tended to learn is the minute we have information, we want more information. We want it more often, and we want it more fine grain. And the more we get, the more we can learn about how to improve things. So this is that same scenario where even though we didn't have a target when this design team started, we went back and calculated it using the tool that we use in Minnesota. We did have a predicted number, and then our actual was a little bit below that, which is good. And you know, honestly, the first time that we talked in our firm and we said, we're going to go back now like a few years, and every project we do going forward, we've been telling our clients we do very energy efficient design, and we've been telling them what we predict their outcome is going to be. They maybe didn't understand it, but we've told them. Now we're going to go ask them for what actually happened, and we're going to show them. And so there was a little bit of a panic that ran through our firm about, you know, what if it's bad? You know, who's going to pay us to do this, and what if it's wrong? And what we found out, and we've done this for dozens and dozens of buildings, is usually it looks like this. Usually the models are a little conservative and it's better. When it's not, we find out what's wrong and we help the client fix it. And it's usually not something we did or any one individual or part of the team did. Something changed over time. You know, we tend to manage buildings, building energy to manage human comfort. So somebody's cold in one room one day of the year, an adjustment gets made and it doesn't get changed. So we have to be able to balance that with the energy efficiency. Here's that same relationship I talked about carbon, and here's where I'm going to talk about cost. So up until a couple of years ago, and it would never fail, I mean, I've been given presentations like this for a very long time. Without exception, someone will always say, okay, you have an energy efficient building, great. How much did that cost? And what people usually mean is, how much more did you pay to build that building to make it energy efficient? And the answer for a long time, and probably for a long time to come, will be, if you can read in the upper right, and I know the numbers on this building. So it's an $8 million building. I can go back to a report that says we had a list of things that we did to make it more energy efficient, and they cost $750,000, so a little less than 10%. Well, that sounds like a lot, but it saves $75,000 a year. So it pays itself back in 10 years, which is about a 10% return on investment, so that sounds okay. There's so many flaws in that logic, not the least of which it assumes that energy costs will never go up, that they're going to stay flat. And that never happens, so that's a bad assumption. The other thing is, because I know this project, more than half of that $750,000 went to buy a photovoltaic array on the roof, which was a great thing to do, but it had very little impact on the savings, very little of the $75,000 savings. So the payback for the renewables was very, very high, and for the rest of the building, it was very, very low. So I didn't necessarily come up with this idea, but someone asked me one day about another project. Do you know how much an average building would cost to build like the one you built? So now we've done that math for all the buildings. So in this case, we took an independent look in a manual about cost estimating and said that building a 30% office and 70% warehouse in the metropolitan area of Minnesota in 2004 was about $79 a square foot. And to build this building, we spent $73 a square foot. So the question is, how much more did it cost to make it energy efficient? Probably it costs less. And what it really is it just costs different. You make different decisions. You know, we spent money in different areas. But the bottom line is, and I absolutely maintain this, it does not cost more money to make a building energy efficient or manage water better. It's just a matter of spending the money differently. So I'm going to go into our last category and talk about human wellness. And in the time that we've been dealing with this issue, this human wellness has changed a lot. When we first started talking about designing buildings for the health of the occupants, I'm not sure if people will remember this, but there used to be things called sick building syndrome and building-related illness. People actually got sick from going into buildings. And we actually worked for a number of clients who had what they called multiple chemical sensitivity, which is still not common, but exists, where people go into a space and from a combination of effects, whether it's lack of daylighting, lack of ventilation, off-gassing materials, they actually become less healthy going into a building. Well, that's pretty depressing, being in a business where you get up every morning and you make a building that makes people less healthy. So I think one of the things that programs like LEED have done is change that pretty dramatically. Now we really have a better understanding. We can't put all this data into a computer and model it and say how healthy is it, and I don't know if that'll ever happen, but we know a lot of good things to do. So we prevent mold and moisture because that was a very big problem. Mold and moisture has very bad effects on people and buildings. So now we design buildings to keep water out. And it sounds pretty basic, but 10 years ago in residential construction, we didn't do that. We didn't know quite how to do that. We've increased daylighting. Elizabeth talked about that. It has very, very positive impacts, and it shouldn't surprise you. You'll probably feel a lot more comfortable when you walk outside on a day like today after being in this space. We increased ventilation, which can counter energy efficiency, but it doesn't have to. We have things like heat exchangers today. We can actually ventilate buildings and do it with very little energy impact. Increasing direct control. I'm not sure how many people are like this, but if I'm in a room all day full of windows and I can't open the window, it actually has a negative effect on me. I may not open the window, but if I can open the window and I know I can open the window, it's good. So you could put the dial on the wall and have it not do anything, I suppose, but theoretically, if you have the dial on the wall and it actually changes things, that's good for people. And the last one, reduce off-gassing materials. We do that pretty much uniformly now. 20 years ago when you started to talk to people about specifying low VOC paints or formaldehyde-free products, that was pretty unusual, and it took a while, but I think that's changed pretty dramatically now. It's not a cost increase. So again, the outcomes, you think about the outcomes in terms of benefits to your human health, and that's pretty obvious. What's really interesting is the economic outcome. I talked about, and I know these numbers roughly for an office building, energy costs in an office building per square foot is about $2. If I'm going to want to own or rent space in an office building, it's about $20 per square foot, roughly, in downtown Minneapolis. So if I take the people who work in that office space, just their direct costs, just their salary and their direct benefits, it's about $200 a square foot. So 10 times more than the cost of renting the space. So in other words, if I can make the people who work in that space 1% more productive, it might be really hard to prove or measure, but if I could, that equates to the entire cost of the energy of that space. So people who run businesses, large businesses with a lot of people, they know this and they understand it. It is difficult to measure, and not everybody gets it, but there's really, if you're doing something like adding daylighting or ventilation and there's no downside to it, you know that there's a huge potential upside. Very difficult to measure. This is one of the first metrics I got 5 years ago. I called up somebody in our finance department and I said, can you tell me in our firm, by physical location, for 1 year, the average numbers of sick time per person? And it literally took the person like 3 minutes. So I've had that information for 5 years. I still haven't done anything with it. Both of our offices are actually building new space for the first time in 10 years. Might be interesting to see what happens if there's a change, bit depending on how we do the space. So more and more people are talking about things you can actually measure as it relates to human health. And now I'm going to turn it back to wrap it up.
Okay, so you know what this is? It's an igloo. We might say that it is a very sustainable building. It comes from the snow right around the site. You build it by hand. You don't need any energy besides food to build it. It keeps you really warm, really lots of insulation in the wintertime. And once it's done, you don't have to send it to the landfill. It just sort of melts and goes right back into the earth. In Alaska and Canada, great strategy. In Nebraska, not so great a strategy. You might build it in January and the next week it'll be 50 degrees and melt your igloo. So we have regionally specific strategies that are really important to think about. So the teepee is a great example of Nebraska Plains specific sustainable building. It comes right from the prairie. The buffalo that are caught to create the skin. Every part of it is used. Nothing goes to waste. It's very transportable. You can take it to a lot of different sites and situate the sites in a variety of ways. This strategy for sustainable design is not so great of a strategy for Alaska or Canada. So it's really important to think about the place where you are designing buildings when you're trying to choose what strategies might work best. Also, something really important to talk about is what the need is. So in the building on the right is a building designed for a pretty dense urban area in Minneapolis. It has a green roof. So it provides a little bit of green space for the people in the building. They're surrounded by a lot of concrete. It's great for wildlife that comes and enjoys the flowers on the roof. And it also traps some of that stormwater we were talking about, trying to slow it down and filter it before it goes out into lakes and streams. On the left is a building that we designed for that's surrounded by natural lands. And so instead of using that roof for green space, the strategy here was to really take all of the water on the roof and capture that and use it for water collection as opposed to green roof. So important to think about the region as well as what needs you're designing for when choosing your strategies. So returning to this first slide, there are lots of topics that we need to consider in sustainable design across many scales. These topics and scales affect the domains of economic, environmental, and social sustainability. And then also critical is to measure the performance so that we know if these strategies that we're choosing actually do make an impact and we can continue to improve and improve the way we design, build, and inhabit our buildings. And all four of these, topic, scale, domain, and performance, it's really important to think very holistically about how topics influence domains and performance can really influence the economic aspects of the building and really think across topic, scale, domain, and performance. So really, if you're going to take away one thing from this presentation, this is the slide. The approach that we take to designing sustainably. First, establishing an integrated approach so that the designers, builders, people who are going to operate the building and the people who are going to live and work in the buildings really work together throughout the whole process. Understanding really what the needs of the people who are going to be in this building are and what the needs of the climate are. Choosing a set of guidelines so that you can really start to think about all those different topics. We talked about LEED today, but there are many others. Setting goals for how you want your building to perform, and then at the end of the process, it's really kind of the start of the process as well, measuring and refining the performance of your buildings. So we're happy to take questions now.
Covered a lot of territory. Go ahead.
Is radiant energy, like if you have your floor heated, is that efficient?
It is. So the question is radiant energy efficient? And there's really kind of two models that we typically employ. The one that you would be most familiar with is probably radiant floors. So it is very energy efficient because it puts the heat where you need it. Oftentimes in a building, you may not notice it, and I'm not sure if it's true in here, but oftentimes the heat will be supplied up there and returned up there, so it never really gets down here where we actually need it, whereas radiant heat comes up. And the more, to me, a little bit more interesting and new way of doing radiant heating is we do something called displacement ventilation, where we might provide radiant heat on the floor or a forced air heat, but we provide the ventilation by dropping the air down on the floor and letting it come up. So basically, we've actually charted this with smoke tests where when you provide the air at the floor, it actually gravitates to the body. It sort of attracts. So it's efficient because you're putting the heat or the cooling where you want it to be. Absolutely. Yes?
You mentioned that there's approximately a 10% increase in the cost associated with building an efficient building. Do those costs include design costs, or would design costs be in addition to that?
So the question was, first of all, a statement that I said it was 10% more expensive. So I'll start by saying I would say it's not at all more expensive. The example that I gave was to illustrate a point that if you look at a project and you say, you try and extract out things that you spent more money on, which is what we did in that example, things like the renewable energy. The bottom line is, when we start a project, we're given a budget, and that's what the budget is. Everybody wants to get, and it's understandable, the most classrooms per dollar or the most units per dollar. So There are some studies out there. I would say that if you started a project and you didn't take an integrated design approach and you got well into the project, into the design, and someone comes along and says, gee, I need to get a LEED Gold building, and you start to have to add things on, you could accelerate the cost. But I absolutely, unequivocally believe that you can design a building to meet all of these requirements without spending more than you normally would.
What portion of designing a building like that would be associated with the design?
The total of the total construction cost, probably around 10%. And actually, it probably would be, stay closer this way.
Would you repeat his
Oh yeah, sorry. So the question is the percentage of design cost to total cost. It can vary from 3% to 20%, but on average, probably around 10%. And it probably is safe to say that to do some of the things we talk about here probably does cost more in the design phase. Another way to think about this, and this is absolutely no-brainer, if you take a project and you think about three costs, the design costs, which is everything including energy modeling, commissioning, everything that happens up till construction, the construction cost, and then the operating cost of that building, just direct operating costs like maintenance, replacement, and energy over a certain period of time. If you look at those three things, then this approach absolutely will cost less. So whether it costs less on day one, that's my argument, but not everybody would go along with that. So does that answer your question? Yeah.
Do you have any data or comparison rates on remodeling a building versus new?
So the question is comparisons between remodeling and new. And I don't want to do all these, so you just jump in if you have something to add. Generally speaking, I would say that it's more cost effective to renovate than to build new. And certainly if you think about it from the total life cycle costs, all the energy that went into creating the materials and the cost and the labor to get rid of the materials to throw it away, it's not always the case. It's really an individual assessment, and it depends on what you're using it for. We have our office building. Our office is in a building that's 120 years old, which by Minnesota standards is a pretty old building, and it's fantastic. I mean, it would just be a crime to see it go away. So I'd say for the most part, I would say renovating is best. That's the most sustainable thing to do, is to keep the existing building if you can, but it may not be possible.
Yeah, I think we're at the University of Minnesota. We have a separate track for sustainable design and also historic preservation. And this year they're offering classes that are about both historic preservation and sustainable design, because the two strategies are really linked. There's a great phrase I love, that the most sustainable building is the one that's already built. And I think especially in small town Nebraska, when you think about where the existing buildings are, they're often in the downtown areas, and revitalizing, like going into a vacant building in a downtown area, has a lot of benefits for not only taking a building that's already existing cost-wise, but also it's a little bit more walkable. People can go to multiple buildings on one trip, and it also brings a lot of life and vitality into downtown areas.
Go ahead.
Yeah, you talked about the energy use intensity. There was nothing in there relating to climate. You just look at locally here, compare one building to another, and there's not really a standard that you can say compared to a mild climate.
So the question is energy use intensity. We did in fact just talk about it to that region, not necessarily in the climate. And I'm not sure if this will directly answer your question, but once we get that piece of information, we were constantly looking of ways to compare it. So comparing the energy use intensity of an office building in Florida to Minnesota, probably not a good comparison. But if we can compare the energy use of that building in Minnesota to what it should be or could be if it met code, and then compare that relationship to what a building in Florida performs compared to its code, then we can compare them. So in a way we can overcome climate. Just as importantly, in any given location, and for sure in Minnesota, if we compare a building to itself over time, which is really valuable, you always have the question, well, was that caused by weather or was it caused by conservation? So we actually use a very sophisticated methodology to weather normalize. So we're always looking at a comparison to the year if the weather was the same. So there are ways of doing it. It takes more work, and you have to recognize how important it is to spend that time. Will we wear you out? Any more? We'll certainly stick around for a few minutes later for anybody who's here who want to come up and ask questions. No more? All right.
Great.
Thank you
Thanks for
very
having
much
us.
for coming.
Thank you very much. Just a couple of notes. If you haven't signed back here, if you haven't signed in, please do so. Secondly, if any faculty or staff want to join, these folks are going to go to UDET El Toros, and you're more than welcome to follow along and join out there. If you're coming back at 7, this hallway's going to get closed. So we're going to contractors in here to paint. You can still come in the south entrance, but just walk around the hall and come back and come back side. I'll still be here to help you, you know. I'm sure it's not. Yes.
Can I get to the refrigerator? I have orange juice for the bite size tomorrow. Can I get to the refrigerator tomorrow?
Where's it at? In your office?
No, in.
Oh, yeah. Yeah, they're just closing.
Oh, okay.
At 5 o'clock, we're gonna shut this off, this hall.
But I should be able to get into that kind of break for tomorrow morning. Okay.
Thank you very much.
Yes.
Really give her good feedback because she always said, you always just say, oh, you're so wonderful.